All right, so very welcome to our UNAM Thursday seminar. It's my great pleasure and honor to introduce to you Professor Sergey Gaponenko, who is a great scientist, but not only a great scientist, but also a great friend. And indeed, our friendship goes back to the beginning of my career at Belarus University in Turkey. And he has been a mentor, but also a great friend all along. And you heard a lot about him already. He is currently the director of the Institute of Physics, which is part of the National Academy of Sciences in Belarus. Indeed, he was formerly also have been assigned quite high-level senior management positions in Belarus National Academy of Sciences. And I happen to know also he is one of the youngest academician in Belarus.
Youngest.
He has been always considered, particularly with his books, one of the first being optical properties of semiconductor nanocrystals, not quantum dots.
Nanocrystals, yes.
In the field, and indeed recognized by our colleagues in the community. So Sergey has been critical in understanding the density of states effects in complex media in different phenomena, ranging from nanoscale to macro scale, which is, I believe, in itself a major accomplishment. But also, he has developed interest over the years in particularly plasma-enhanced Raman spectroscopy, SIRS, and indeed demonstrated quite high performance, record performance at the time. And one thing you will never find about him, and I can share with you very intimately, is that he is also an enthusiast for building your own speakers, very high quality speakers, and he is known for making very high quality by himself. I also had the privilege to work with him closely on one of his last books. This was quite difficult.
It was our common book.
Yes, this was a great pleasure, and this was an idea we came up while he was visiting NTU Singapore, and we thought this type of book is indeed missing in our field, and I'm very privileged to be part of this successful project. And now this is even available in China, and I hear from my Chinese colleagues it's actually widely recognized and used. Good. So without further ado, today we will be hearing a very special talk. This talk indeed was commissioned by the Turkish Academy of Sciences last year and delivered particularly in Istanbul. So Sergey had to travel once again from this time to Istanbul. And the Academy members indeed heard about Sergey's vision on here for basic science, particularly the mission of Homo sapiens in the universe. I believe being such a humanitarian and a spatial soul Sergey is, I hope we will be all inspired by this spatial talk. Please join me to thank Sergey for his presence.
Okay. Dear colleagues, thank you so much for invitation and for introduction. It is not a regular scientific, you see, tutorial or scientific overview. It is just some willing to share with you some ideas, some feelings which I do feel, and I want to pass certain messages that we should identify our role in universe as very special and as very exclusive, privileged, and very important, This was actually inspired by the conference which have been held a year ago in Istanbul by Turkish Academy of Sciences, and this is exactly the same talk I presented a year ago. I didn't made a change here. So you see that, let me state that the basic sciences is always underestimated, not only by ill-informed customers. Customers generally accept that science is useful. But basic science, it's typically underestimated as a kind of curiosity of some strange people, you see. But even by decision-making governmental experts, they always ask us to prove that this is necessary, this is useful, this is helpful, and so on. And in spite of high recognition by basic sciences, by scientists themselves, and by academic community, there is still need to identify the decisive role of basic sciences in many facets, many fields of human life, including not only education, but including also the basic source of high technologies, the cheapest stage of innovation. Typically basic sciences like high energy accelerators considered as a very expensive pleasure for some curious, strange peasants, you see. Also the efficient way of pupil diplomacy. So this is free, short messages which I will say to share. Maybe you also feel the same, but we together must promote this into society, yes? Into customers, yes, into taxpayers in every country. But afterwards, I suggest to consider that continuous development of scientific worldview by means of basic science can be treated or should be treated as special mission of Homo sapiens in the universe. So let me start with the first. Okay, let me then complete this one. Some animation. Good. Okay. Then let me start with the first. So basic science do form the basis for innovation. Basic sciences represent the first preliminary stage in general innovation chain. However, neither scientists can truly foresee what will be the final societal or economical impact of his discoveries and breakthrough theories. They cannot be foreseen or predicted in advance. I collect just 4 representative examples from the history of physics, which shows that brilliant, genuine scientists cannot foresee the final societal impact of their discoveries. First is theoretical physics as prerequisite for nuclear power plants and weapons. Second, this is classical electrodynamics as the seed for radio and TV communication. Third is quantum mechanics as the background of semiconductor electronics. And then computer science as prerequisite for modern palm-top gadgets, you see. So, and we can speak that high technologies are born by high science. High science produces high technologies. This is very catchy. One expert minister of technology in Belarus says, this is pretty catchy and understandable what you say. Yes, high technology are created by high science. No high science, no high technology. This is example number 1. You see that in 1864, James Clerk Maxwell predicted electromagnetic waves. So this is a necessary component of Bluetooth, Wi-Fi, mobile phones, radio and TV communication. But did he know about this? Surely he didn't know about this. He didn't know about this. And approximately 60 years afterwards, first radio communication had been practically demonstrated by Marconi. Approximately 40 years afterwards, or 40 years past. Another example, I already mentioned, this is a very genuine paper by Jan Albert Einstein in 1905, with very strange title, On the Electrodynamic of Moving Bodies. Yes, should he apply for a grant, he will never win a grant in any, you see, finance and scientific agencies. You see, but it is in this paper, purely theoretical paper, based on his curiosity, that he predicted that energy is related to mass as mc squared. Now we write mc squared. Here he used mu v squared. Yes, this is the formula that energy, the W stands for energy, and this is for mass, this is for... And this is the basics for, you see, nuclear weapons and for atomic power station. 40 years after, people make first nuclear weapon, and 50 years after, people make first atomic station. So, but he did not know about this. Surely he did not know. This quantum mechanics, we now will celebrate 100 years of quantum mechanics. Approximately 100 years ago, de Broglie came up with his first ideas that there should be wavelength assigned to microparticles. Yes, and in 1926, Schrödinger formulated his famous equation and found that this equation can explain atomic levels in hydrogen. But this is actually the basics of solid-state physics and solid-state electronics. Schrödinger didn't plan anything about transistors and didn't plan anything about microchips, you see. And 20 years later, first transistors appeared. First transistor appeared in Bell Labs, where Louis Bruce was working, in the same building. And this invention of transistor also were awarded with Nobel Prize. And there is the only physicist in the world who got 2 Nobel Prizes in physics. This is Bardeen, first prize for transistors and second for theory of superconductivity. He was working in Bell Labs. The only physicist. This is what you see, what company pay, what company contribute to basic science, actually, to basic science. Strong companies. And 40 years after this equation, you see, first laser, also Dirac. Dirac in 1927, Dirac made foundation of quantum electrodynamics. And 40 years later, first laser appeared, and 40 years later, commercial microchips appear. But these people did not plan neither laser, nor microchips, nor transistors, you see, and so on. This was basic science, you see, and computer science. So who can imagine that very big calculators from my student time will evolve to these gadgets of junior schoolboys. You see, in 40 years, this happens. This is important person, Norbert Wiener and John von Neumann. I remember this calculator like this, based on transistors and inductance. You see, discrete inductance. It's amazing. Yeah, so this is something related to nano. I wanted to show that I'm related to nano. And now I want to challenge, I already did yesterday, but I didn't change everything, didn't change anything. This was done a year ago. That we still do not know what will be the final societal impact of nanotechnologies for society. So think about, you have smart minds, you are clever, you're smart, and you are young. This is very important, yes, you have fantasy. So think about what will be actually, there should be something which cannot otherwise exist without nanotechnology. You see, mobile phone, monitor, TV set, you see radio set, you see communication, glasses, micro display, all these transistors, light emitting diode, lasers, all these things exist independent of nanotechnology. They become better, faster, cheaper, lighter, you see, and so on. More options, yes, but it's still mechanical, incremental progress. Let us look for something which did not exist and appears and finally only owing to nanotechnology. Yes, I don't know, maybe something nano-bio sensors, you see, biocomputer, maybe something like this, and so on and so forth. Yes, then another message. So this message, this is basic for technology, but typically it is not foreseen at the moment, yes? And then another message, this is the cheapest stage of, this is counterintuitive. Many people believe that basic science is expensive. The most expensive basic science project I know, this is this Large Hadron Collider, which this is a big European mega project. And the cost was 11 billion euro. You can get it in from Wikipedia. 11 billion euros. This is big. As compared to our salaries, it's big. Yes. Okay. As compared to the cost of our house. That's apartment for one family. That's big. But what should be the correct scale, the correct, you see, subject for comparison? Relevant. Let's consider how much money Intel put into R&D. And you will see from official research of Intel that every year Intel does put the same amount into its commercial research and development. Every year Intel is capable to build another Hadron Collider. If you consider other companies, this is the reference. This is the reference for Intel. This is reference for Hadron Collider. You see, this is reference for other companies. Huawei contributes 2 times more than Intel. $20 billion every year Huawei contributes puts to research and development. So basic science is not wasting money. This is the cheapest one, the cheapest. Developments, industrial science, much more expensive, much more expensive. Then, basic science unites people. Unites people. This is my personal experience, you see, from different countries. Just a month ago I was in India, I told. A week ago I was in Saudi Arabia. Yes, in next month I will go to China. You see, now I'm here, you see again back to Bilkent. You see, and basic science is a bright manifestation of science diplomacy. This is a kind of people diplomacy. Yes, people diplomacy, this is official, not a conception, it exists, yes. It exists. What diplomats or politicians cannot do, then people do themselves, yes. Yes, and they bridge people of different races, basic sciences, basic research, bridge people of different races, of different religions, different cultures. And it is favored by the 2 important properties. That first one, we do need to join our efforts because major basic problems are multidisciplinary, and we have to join our facilities and to join our background, to join our minds and our skills, yes? The first favor of this. And the second, which is important, there is no commercial secrets between us in basic science. So we can cooperate immediately without any problems, without writing non-disclosure agreement, without evaluating commercial output and so on. And this helps us to become very friendly, yes? So this is also important. No classified work, no secret data, so openness of basic research. Openness of basic research. Now, I get closer to my major message. You see, I introduce the conception of cosmoethics. I didn't learn, this is my personal impression, personal feeling, and I will express what is it. If you consider what ethic is, I would say that this is ethic teach us how to respect each other, how to love other humans, yes, how to take care of each other, no violence between people, sharing common resources. There is, in the beginning of our century, there is another propagation, prolongation, extension of this ethic conception, eco-ethics, eco-ethics, safe nature, no waste, no kill, do not kill animals, yes, spare and safe nature, respect nature, leave natural resources for future generations. Leave natural resources for future. Leave plants and animals to other generation of humans. This is called eco-ethics. This is reference for this where you can learn what is it. Yes. You see, from environmental ethics to nature conservation policy. Yes, you see, the Journal of Agricultural and Environmental Ethics, you see. So this is eco-ethics. And I would like to extend ethic notation to cosmoethic. What is cosmoethic? Feeling of our personal responsibility for the presence of human beings, of Homo sapiens, in the universe. We must live responsibly. Yes, we must feel ourselves, do not waste our life for nothing. Do not spend, you see, energy for nothing. Do not kill each other. Do not kill other animals if you don't need this to survive. You see, animals kill each other to survive. People kill each other. Just for territory, for money? I don't know. Certainly, definitely not in order to survive. Somebody maybe kills somebody to survive, but typically people make war not to survive. Not to survive, to get more, to become more rich and so on and so forth. So, for our presence in this, and in this case, you see, in this case, in terms of cosmoethic, we feel that we are responsible, since we are Homo sapiens, we have mind, we are able to conceive, you see, to conceive properly, relevantly, our universe, its construction, its organization. We ought to put a lot of efforts to this. Because elephants or wolves cannot do this. Cannot do this. Only humans can do this. Only humans can do this. And this is also a portion, a component of cosmoethic feeling that humans should conceive the universe. And this is the mission of scientists then, yes? Think about. This is a kind of our universe scale mission. So then I am coming to conclusion that continuous development of the scientific worldview is a major societal gain resulting from basic science. Not the first step of technology, but this contribution to the universe scale mission, you see. Technology is secondary. Technology is something good for people, yes? Yes? If elephants will think to make only something good for elephants, we will not be very happy. Okay? Do elephants happy that we are making technologies for people? I don't think so. But this is universal. We can speak to elephants, to dogs, that we are special portion of universe, that universe create us to be recognized, to be understood, you see, that we built research picture worldwide worldview. We consider, we develop scientific worldview. And this is, you see, we don't need any other arguments to do this. You see, this is just our mission. No arguments is necessary. We should put this to governmental experts, to speak to this to other governmental experts, you see. So I suggest to identify this role of basic sciences as a decisive contribution to the overall human culture on the human civilization level, to conceive the harmony of nature, to elaborate the relevant scientific worldview, to reproduce the structure and organization of the universe from subatomic to molecular and supramolecular level, and further to the astronomical scale, involving physical, chemical, biological, all interdisciplinary issues. All this is to be treated as an important, naturally arising and responsible mission of human beings. We ought to transfer continuously developed scientific worldview to succeeding human generation for further development. Neither human himself can keep in mind all worldview, yes. Only generation is able, and the generation must pass this code to the future generation, finally, yes, to the future generation. We also should do our best in search for possibly existing extraterrestrial intelligence, yes? And if you find extraterrestrial intelligence, we ought to join our efforts with them in this mission, So with this statement, let me say thank you so much for your attention. That's all.